the last video I left off with the idea of a calorimetry problem, and this is going to be a video that works through one. So I'm going to start with the cup of water that I had in that example. Got a cup of water, and inside of it I have, let's say, 500 grams of water. And I'm going to put this at 20 degrees Celsius. I'm going to drop into here a cube made of, let's go with aluminum. This thing can have a mass of 50 grams. And it's going to start at 60 degrees Celsius. I'm going to put a lid on here, and I would like to find the final temperature. So first I'm going to need some numbers. The specific heat, or the heat capacity for aluminum, is going to be 900 joules per kilogram Kelvin, and the heat capacity for water is 4186 joules per kilogram Kelvin. I want to make a couple of, guesses, I suppose. Set up a couple of markers ahead of time. First, I've got this water at 20 degrees Celsius and this cube at 60 degrees Celsius, so I know my range. The range for my answer is I'm going to be somewhere between 20 degrees and 60 degrees. I've got more water than I do aluminum, so I'm expecting that I'm going to be closer to the 20 degree mark. If I do this whole thing and I get 40 degrees, I will know that I've done something wrong. If I get something outside the 20 to 60 range, I'll definitely know that I've done something wrong. So that's going to be my broad scale consistency check. All right, the heat lost by the cube. I'm going to have an MC delta T. Now that delta T, I'm going to come back to that, but that's where all my action is going to be. The heat picked up by the water is going to be an MC delta T, and I want the one to equal the negative of the other. It's the negative because this thing is going to have a delta T that's a negative number. This thing's going to have a delta T that's a positive number because the metal's going to cool down and the water's going to heat up. So the heat that's given off by the cube has to be picked up by the water, which means the water is giving off negative heat. Maybe that's a good way to think about that. Alright, now these temperature changes, those are where we are going to do this problem. The temperature change for the cube, we know temperature change is always going to be a T final minus a T initial. T final is what we're looking for, minus T initial. And I'm going to do the same thing over here. So I'll move this over just a little bit first. But for the water, I'm going to have a T final minus T initial. I'm going to distribute the MC through, so I'm going to get a mass times C times T final minus a mass times C times T initial equals, I'm going to have a negative MC T final, and a minus makes a plus, so plus MC T initial. I'm using the different colors just to avoid throwing subscripts on everything, but the black is for the aluminum, the blue is for the water. I'm going to take all my terms that have that T final in them and move them to one side. So my left side says MC T final plus MC T final equals MCT initial plus MCT initial. I'm solving for T final, so I'm going to factor that out here. And over on the right side, the T initials are still different also. So if I am solving for that T final, that's all I need to do is divide. And now I'll move this and plug in some numbers. So I get the mass of water, 500 grams, times the heat capacity for water, times the initial temperature for the water. I need these temperatures to be, it can actually be in Kelvin or Celsius, it doesn't matter. So I'm going to leave this one as Celsius, just to show you it doesn't matter. Over here I've got 50 grams, so 0.05 kilograms, 900 joules per kilogram Kelvin, and T initial was 60 degrees Celsius. And I get a final temperature of 20.84 degrees Celsius. I did end up with a number that was between 20 and 60. It's a whole lot closer to the 20 than it is to the 60, so this checks out. The only assumption that I have made in this whole thing is that all the heat from my block goes into the water. That doesn't have to be the case. We could have a case where the cup itself heats up or where something else is going on, but those are messier problems and they're not really the kind that you're going to come across. So whatever heat the one gives off, the other picks up, and then it's just going through the algebra.